Hello everyone, welcome to the another lecture of atomic structure and chemical bonding class 9. Myself Suman Singh. So in the last class we have discussed about the discovery of electrons. So now in this class we will discuss about the discovery of protons by Goldstein. Okay, so, when we talk about the discovery of electrons in the previous lecture, there we have seen some experiment, okay, cathode ray experiment. So, in this, the discovery of proton is almost same. We can say that the everything is same, the arrangement is same. There is a slightly this arrangement are same as that of the cathode ray experiment, but there is a slightly difference in experiment, or we can say that arrangement. So what was the arrangement and how we Goldstein has discovered this cathode protons, we will see that. So the arrangement was like this. He has taken one discharge tube like this. Okay, he has taken a discharge tube like this, and in this discharge tube he has taken cathode here and anode plate here. Okay, this one is a cathode plate which is negative charge, and this one is anode plate which is positively charged. Okay, and this one he has connected this with the battery high voltage. We can say this he has connected with the high voltage. This was the basic experiment arrangement, but there is a difference where the difference lies here. Okay, in the J.J. Thomson experiment you have seen that the electrode was same. Okay, both the electrode was same, but here in the discovery of proton, the in the electrode there is a difference in cathode. Okay, so suppose this is a cathode. In this cathode he has used here perforated cathode. Okay, perforated cathode means what? There is a hole, small hole in the cathode. Okay, so now what he observed, Goldstein, what he has made this like this arrangement, and everything was same. He has used a gases here. Okay, he has used a gases here, and he has used here vacuum pump to reduce the pressure. Everything is same as that of the cathode ray experiment. So what he observed, Goldstein has observed that since first of all we will see the discovery of electron. In the discovery of electron, one ray was generating from the cathode and moving towards the anode like this, right? Like this, like this. Okay, one ray was generating from the cathode and moving towards the anode in J.J. Thomson discovery of electron experiment. But Goldstein had observed that simultaneously one some rays are generating from the anode and moving towards the cathode. Simultaneously, some rays are generating from the anode, and just it is passing through that hole perforated. Since it has taken here hole, but there is a hole in the cathode, so it was passing from that hole and it was traveling here. Okay, Goldstein has observed that simultaneously the way ray was traveling from cathode to anode, in the same way one ray was traveling from anode to cathode, and this anode to cathode ray was, since there is a perforated cathode, so that is why this ray was passing through that hole and it is coming here. And this rays what was generated here, Goldstein has given the name to this rays as proton. Okay, okay, proton or positive rays. Okay, so now after the discovery of this rays, he tried to know the properties of this rays. So what he observed that this the way he observed that anode ray travel in a straight line. As you can see, this anode ray is traveling in a straight line, as in the, okay. Next thing what he observed that this anode ray consists of minute particles, okay, small particles, and because of the presence of this small particles, this rays produces a mechanical effect. As I have discussed about the mechanical effect in the previous lecture, in the when we were discussing about the cathode ray, at that time where I have used here pedal wheel, right, like this. So when the ray was striking this pedal wheel, this pedal wheel was rotating. So then, since rotation is what, it is a mechanical effect. So he shows the same thing. He told that this uh, positive rays consist of minute particles, and hence it produces a mechanical effect. Next, what he told that this ray is positively charged, or we can say that the particles which is present in these rays are positively charged. How he came to know about this? He has done the same thing what J.J. Thomson has did. He has used here electric discharge, positive and negative. Here he has suppose taken negative, here he has taken negative positive. So what he observed that the ray was traveling towards the positive side. Sorry, here he has taken negative, here he has taken positive. So what he observed that the ray was traveling towards the negative side. Okay, so as we all know that who will travel towards negative, the one which will be positive, right? So he observed that this ray was traveling towards the positive side, negative side. Why it is traveling towards the negative side? Because this ray is positively charged, and all the particles which is present in these rays are positively charged. Okay, now again he has used magnetic field, just like north pole and south pole in the experiment we have seen in the J.J. Thomson experiment. So again he has also used here magnetic field. So when he used here magnetic field, at that time, if he expected that if it is a positive, it will move towards the south pole, the ray will move towards the south pole. The ray has behaved the same thing what Goldstein has observed, or what he has supposed. Okay, now again what he told that this ray produces a fluorescence. About this we have discussed in the cathode experiment. So what he told that this ray produces fluorescence on the zinc sulfide screen. What he observed, he told what he observed that if we are using here zinc sulfide plate, if I am using here zinc sulfide plate, or we here if we are using a zinc sulfide plate, at that time it produces a fluorescence. It produces a fluorescence. Okay, okay, it produces a fluorescence if we are using a zinc sulfide plate. So I hope from up to here you have understood. Next, what he told that the charge by mass ratio, okay, E by M ratio, we have discussed, right, this one, E by M ratio. So he told that E by M ratio will differs from gas to gas. Means if we are using hydrogen gas, the charge by mass ratio will be different to that of if we are using their helium gas. Means if we are it means what we can say, if we are using helium, then the charge to mass ratio will be different. If we are using hydrogen, charge to mass will be different. If we are using any other gas, neon, argon, any other gas, the charge by mass will differ from gas to gas. Okay, and it will be maximum when we use hydrogen gas in a discharge tube. If in a discharge tube we are taking hydrogen gas, at that time this charge by mass ratio will be maximum. Okay, now after that what is told that this, I hope you have understood this, I'm erasing this diagram. So what he told that this proton possesses a unit positive charge of +1 and its value is plus 1.602 into 10 to the power minus 19 coulomb. Okay, as we have seen that the charge of an electron is minus 1.602 into 10 to the power minus 19 coulomb. In the same way, the charge of the proton is plus 1.602 into 10 to the power minus 19 coulomb. Okay, now when we talk about the mass, its mass is same as that of the hydrogen, which is 1 atomic mass unit. As you can see, AMU means atomic mass unit. Okay, and which is 1837 times the mass of an electron, which is 1.672 into 10 to the power minus 24 gram. Okay, now next, what you told that the proton reside in the center part of the atom in the nucleus. Means what? If this is an atom, here the proton will be here with it will reside here with in under the nucleus. Okay, so this was all about the discovery of proton. I hope you have understood this. Now after the discovery of proton and electrons, Sir J.J. Thomson has given a model of atom, and in this model he tried to explain how proton and electron used to exist in an atom, or we can say that how these electrons and protons reside in an atom. So what he told that he told that I will give you a simple example. Have you seen watermelon ever? So in that watermelon, it is like this, right? The center part, if you will see, if you will cut into half, you will see that it is like this, right? Red or red in color. In the if you will cut it half, it will be like this. So he told that the if you take the example of watermelon, the reddest part is proton, and the seeds which are embedded in it is a electron. Okay, what he told that it's exactly the same. What he told that the reddest part is what? The reddest part of the watermelon is proton, and the seed which is present in the watermelon is called electron. Okay, and or else what we can say, according to this model, an atom is considered to be a sphere, as you can see here, of uniform positive charge. This pink part is uniformly distributed, as you can see. So this pink part, he told that this is a positive charge, and the electrons are embedded in it, just like the black dot you can see in the pink part. This is a, what he told that this is electron, and the pink part is a positive charge. Now next, what he's told that the total positive charge is equal to the total negative charge. That is why the whole atom is electrically neutral. Means what? He told that the total positive charge will be equal to total negative charge. Okay, that is why atom is electrically neutral. Next, what he observed, the mass of an atom is considered to be uniformly distributed. And after that, what he told that the mass of the atom is uniformly distributed, as you can see here in this case. Okay, so this was all about J.J. Thomson plum pudding model, or in some book you will say watermelon model. Okay, so this was all about J.J. Thomson plum pudding model. I hope all of you have understood this. So after the J.J. Thomson has given this plum pudding model, another scientist named Lord Rutherford. He was a New Zealand scientist from New Zealand. In 1911, what he did one experiment, and through that experiment we have came to know about how actually this electron and proton used to reside, or we can say that used to exist or used to live in the atom. So what was his experiment, we will see now. So his experiment was like this. He has taken one gold fuel like this. Okay, he has taken one very thin gold fuel, and when we will see the size of this gold fuel, it will be 1 by millionth of a centimeter, means very thin. Okay, and he's why he selected the gold fuel, because we know that the gold is highly malleable, right? It can be drawn into a very thinner and thinner sheets. He has taken this gold fuel, and he has taken the sources of alpha particle. I will tell you about the alpha particle. Alpha particle is what? It is a positive charge particle. Okay, or we can say that it is a positive charge ray. In that ray there is a positive charge material. Okay, so he has taken alpha particle, and suppose this is the source of alpha particle here. Suppose this is the source of alpha particle. Okay, there is a source of alpha particle. So when he has started this experiment, he observed that when the alpha particle was going from here and striking this particle like this, this when it was striking this gold fuel like this, most of the alpha particle pass straight through the fuel, means there was not having any deviation. It was just passing as it is. Most of the alpha particle was passing as it is, you can see here. Okay, what you observed, most of the alpha particle passes straight through the fuel, means when it is striking the fuel, it is just gold fuel, it is just penetrating it and it is going straight without any deviation. Okay, next what is observed, some of the alpha particle is deflected to a very small angle, just like this. Okay, some of the alpha particle is deflected to some angle, just like this. Okay, some of the alpha particle deflected to some angle, just like this. The green one, you can say it is deflecting, right? It is not going straight, it is just deflecting like this. It is deflecting. Next what he observed, a very few, means what, 1 in 10,000 of the alpha particle. When suppose what he means to say here, if we are just bombarding 10,000 alpha particle on this fuel, at that time only one of them is bouncing back to 180-degree, or we can say that it is completely bouncing back to a large angle, just like this. I will draw it little bit bigger so that you can understand it very carefully, very clearly. So suppose this is the alpha particle and it is just striking this and coming straight here. Okay, so what he told that 1 in 10,000 of the alpha particle is deflected by a very large angle or completely bouncing back. So this was the experiment of Rutherford. Now, through this experiment, what he concluded? He concluded that the first case, the atom, what he told, or what he concluded, that he concluded that the atom contains a large empty space. Why he told like this, or why he concluded like this? Because you can see that most of the alpha particle, just striking here and just going straight, right, like this. It is just traveling straight here without any deviation, right? That is why he told that, he concluded that uh, most of the atom consists of large empty space, and that is why most of the alpha particle pass through the metal fuel without any deviation from its path. Okay, next he told that there is a positive charged mass at the center of the atom. Okay, there is a positive charge mass at the center of the atom, which he has given the name nucleus. And he told that in the nucleus the entire mass of atom is concentrated. I hope you are understanding. He told that there is a positive charge at the center of the nucleus, at the center of the atom, and he has given the name as nucleus. And in that nucleus the entire mass of the atom is concentrated. Okay, that is why when the alpha particle, since I have told you that alpha particle is also positive charge particle, and when it is striking that nucleus it is completely bouncing back. Why? You know that the positive and positive repel each other. That is why you can see this one, it is completely bouncing back, right? Why? Because it is this ray, since it is a positive ray alpha particle, it is striking to that nucleus. That is why it is completely bouncing. But in the case of this they are not just they are not colliding, or we can say that they are not striking that nucleus. That is why he told that, therefore what we can say, the nucleus is the densest part of the atom. Okay, and the electrically positive nature of the nucleus is supported by the fact that the positively charged alpha particle approaching the nucleus get deflected. Okay, and what does this prove? This proves that nucleus contain protons. Okay, means what? Inside the nucleus there is a proton. Now again, when we talk about the size of the nucleus, the size of the nucleus is very small. Okay, it is very small as compared to that of the atom. And this, how you can prove this? This is proved by the fact that most of the alpha particle passes through the straight line of the through the passes through a straight through the gold fuel. Okay, why? If there is a nucleus, if suppose the size of the nucleus will be big, at that time this ray will also strike, right? This ray can also strike, this ray can also strike, but it is not like this. So that is why he concluded that the size of the nucleus is very small as compared to the size of the atom. This proved by the fact that most of the alpha particle passes straight through the gold field. Now next what he told that, I am just erasing this. Next, what he told that the nucleus is at the center. Nucleus is at the center. Okay, like this, and the electrons are revolving around the nucleus. The electron is in the center, and the electron revolve around the nucleus at a large distance from each other and form a nucleus. Okay, in a circular orbit found in an empty space of an atom. Okay, you can see this. The electron is just, this one is electron, here it is electron, here it is electron. It is revolving, like this around the nucleus. This one is what? This one is nucleus. Okay, now what he told about the neutrality of the atom, why the atom is neutral. So why he told that an atom as a whole is electrically neutral because the total positive charge of the nucleus, whatever the positive charge present in the nucleus, is balanced by the total negative charge of the electron. Whatever the electron negative charge present in the electron and whatever the positive charge present in this nucleus is balanced each other. Okay, and that is why he told that the number of proton and electrons are equal in a neutral atom. Okay, since the number of electron and protons are equal in a neutral atom. That is why the charge or negative charge of the electron and positive charge of the nucleus is balanced each other. Now next, what he told that the electron revolve around the nucleus in a circular path, which he has given the name orbit. This circular path he has given the name as orbit. Okay, the electron revolve around the nucleus in a circular path, which he has given the name orbit. The circular path he has given the name orbit. Okay, and the force of attraction, as you know that the electron is negatively charged and the proton is positively charged, they will attract each other, right? Why? Because negative charge and positive charge attract each other. That is why the force of attraction between the negative charge electron and the positive charge nucleus is counterbalanced. How it is balanced? It is balanced by the centrifugal force acquired by the revolving electron. Means what? When this electron is revolving around the nucleus, it is producing a centrifugal force. So this through because of this centrifugal force, the positive charge of the nucleus and the negative charge of the electrons are balancing each other. He has also given an example just like the sun in a solar system. In our solar system, sun is at the center. So he has given he told that the sun is a nucleus, and since the planets are revolving around the sun, he has given the name the planets. He told that he has compared that the planets are electrons and the sun is a nucleus, and the planets as the planets are revolving around the sun, in the same way the electrons are revolving around the nucleus. Okay, so this was all about the Rutherford atomic model. So but there is a drawback. Why there is a drawback? Because this Rutherford atomic model does not describe the stability. How? We will learn that. As we know that if any electrically charged particles, according to the classical law of mechanics, or we can say the classical physics, if any charged particle is rotating, you have to listen carefully because this is a very complicated part. So according to the classical law of mechanics, any electrically charged particle, if it is in a motion, okay, it will radiate energy. Okay, so thus an electron when revolving around the nucleus continuously, it will also radiate its energy, means it will lose its energy. Okay, as a result, what will happen? A time will come when this electron will go and collide with the nucleus, right? How? Suppose this is a nucleus here and electron is revolving like this. So as I have, according to classical physics, the electron, whenever any charged particle, since electron is a negatively charged particle, when it will move around the nucleus, it will radiate some energy. Okay, it will radiate some energy like this. It will radiate some energy, and means it will lose some energy, and by this, like this, one time will come, this will go and collide with this nucleus, right? Go and collide with this nucleus. So in this case, what will happen? The atom will become highly unstable, and hence the matter will not exist. So this was the drawback of this Rutherford. What Rutherford has told, that electrons and electron is revolving around the nucleus, and there's a positive charge of the electron nucleus and the negative charge of the electron is balanced by centrifugal force. This part has completely failed, because according to classical physics, when any charged particle is rotating around another positive charge, another charged particle, it will radiate energy, and one time will come, it will go and collide with this. In this case, the atom will not exist, right? So this was the drawback of Rutherford model. So this through this experiment, or through this uh, drawback, what we can say that this Rutherford experiment has failed to explain the stability of the atom. Okay, so I hope you have understood this about the Rutherford experiment. So keep up to this. In the next class, or in the next lecture, we will discussed about the Bohr atomic model and atomic structure, atomic number, like this. Okay, discovery of neutron and all. Till that, thank you.